Let's go back to Alice and Bob. Suppose Bob says, I need a fish bowl. That is, I need something that will take my fish and keep it happy and alive. What if Alice says, hey, here's a bowl made especially for colorful fish. Give it a fish with colors, and it'll keep it happy and alive. It works by constantly monitoring the fish's color to make sure that it's a healthy glow. Bob's not going to be happy with this because his fish doesn't have color, and when the bowl tries to monitor the color, it won't be there, there will be an error, his fish will die. So we want to make sure that a function that takes a record with extra fields is not a subtype of a function that takes a record with certain fields. We can put that in code again. Here's the function f that takes a function g, and this time g takes a record and returns a number. So we'll call g with a record that has an x field. If I try to provide a function that wants a record that has an x and a y field, it might try to get the y field out. If we were allowed to pass this in for g, g would send it a record with only a y field, we would get a field not found error. So in fact, for these two types, we do not want the first one to be a subtype of the second one. That is, we don't want to allow tal1 here to be a subtype of tal1 over here. Right? Our type rule right now is correctly rejecting that program. There is something we can do about tal1s to make it more general, though. Suppose Bob says, I need a fish bowl that will work for my red fish. He's got a colorful fish now. If Alice says, well, here's a bowl that works for any fish, then Bob is going to be happy. That is, if we wanted a bowl that works for specifically color fish, and we get a more general bowl, right, a bowl that can take any kind of fish, then Bob will be happy. It's a kind of strange thing here that things flip around. A bowl that's more general is rarer than a bowl that works specifically for colorful fish. Let's try this again in code. Here we see that we have a f wants a function g, where g is going to be given a record that has at least x and y, and it's supposed to give a number back. So we can pass g this record with x1 and y2, and it's supposed to give us a number back. Here I'm going to provide f with a function that expects a record that has at least x. And you can see that when we run, this will be fine. It'll get a record that has x and y, but it's okay to pass more fields into a function. It'll just pull out the x and everything will be fine. In other words, we want this type, this function type, with a record containing x to be a subtype of the function type where the argument is a record containing x and y. Right? So we want the top one to be a subtype of the bottom one, and we get that by allowing tal1 prime, the argument type of the second function, to be a subtype of the first one. And you see that the tal1s and tal1 primes are kind of backwards compared to everything else. Right? The tal2s, the result types, follow the same direction as the function type, where the tal1s, the argument types, are turned around. Right? And we have words for this effect.